All right, now that we have our bearings, we're going to should be able to just comb right through this example. We're given the same information. P is still 0.42 and is still 110. We've already computed Q to be 0.58. And our question now, we want to say, what is the probability that P hat is greater than 0.53? And so this should follow the previous lines very, very similarly. All right, so we have our normal curve. This is the Z scale, this is the P hat scale. This is centered at 0.42. And we want to find the probability that P is greater than 0.53. 0.53 on this scale, this is the x-axis. So 0.53 is here. And we want everything greater than. So that means we want everything to the right, which means we want this shaded area. This shaded area must match the interval of interest. That value gives that value, gives that value. This arrow always goes to the left. That value must match this. That must match this. This always goes to the left no matter what. The fact that the arrow does not match what we're looking for means when we find the table value, we have more arithmetic to do. All right, so let's plod merrily along here. So our z-score is P hat minus P over square root P times Q over N, which in this scenario is 0.53 is the P hat value of interest, 0.53, minus the given value for population proportion, and then substitute the values in that we know, 0.42, 0.58, and 110. 0.42, 0.58, 110, and let's go to the calculator. And so let's see what we generate out of that. I'm going to say open parenthesis 0.53 minus 0.42 close divided by the square root of 0.42 times 0.58 divided by 110, close parenthesis, and I have 2.33749. Rounding off, I'm going to say this is, the value I'm going to use is 2.34. I actually have 2.33749 and so on. We round to 2 decimal places. Remember, if you are off in the last decimal by just a bit, I will be forgiving of that. If you round in a different place than I did, you might slightly get a different rounding result than what I did. That's fine. As long as you have 2.34, 2.33, 2.36, something close to that, you're going to be good to go. You don't need to worry about rounding differently than I do when I make solutions out. If you get 1.72, well, that means you screwed up. You better go fix that. But you should make sure that whatever machine you're using, you can get something reasonably close to that number, accurate to maybe, or you want to have only be off by the last value in the second decimal place. All right. Table value for 2.34, I have 2.3, and since this table is expertly designed, I can go from the bottom up. 2.34 is 0.9904. Table value .99, what did I say that was? 2.34, 9904. And that number goes here, 9904. Our 2.34 goes here. All right. This does not match the value we're looking for. We want everything else, so we need to subtract from 1. Remember, if what you're searching for is less than, the table value is your result. If what you're searching for is greater than, it's 1 minus the table value. And so the probability that P hat is greater than 0.53 is given by 1 minus the 0.9904, which is 0.0096, I believe. And that is sufficient for our work.